Hello, my name is Leo Dumontel, and for this physics experiment, I exploded a watermelon using rubber bands in order to calculate momentum of the biggest chunk, the one I chose, and the kinetic energy in that chunk, as well as the elastic potential energy from the rubber bands. To start off, we bought a watermelon that was 10.5 kilograms, and then we just started the process of putting rubber bands on top of rubber bands. This whole process took around 3 hours. After so long, it finally exploded.
No, it's not! Look at the bottom! Look at the bottom!
After that, I collected my piece and I weighed it on a scale, and it turned out to be 6.4 kilograms. Then, with the assistance of the tracker program, I was able to determine the velocity, which was 3.75 meters per second at the time of explosion. With this information, I was able to calculate the momentum of the piece. The momentum of the chunk resulted to be 24.06 kilograms times meters over seconds. And the kinetic energy of the chunk, being half the mass times the velocity squared, resulted in 45.25 joules. And finally, in order to find the potential elastic energy, I first had to calculate the spring constant. I hung a mass of 0.20 kilograms on one of the rubber bands. I did so by multiplying the mass times the gravity and dividing it by how much the rubber band had stretched. This gave me a spring constant of 11.6. Then, by introducing this spring constant and applying it to the formula of the rubber bands on the watermelon that stretched to 7.5 inches or 19.06 centimeters, I was able to calculate that the potential elastic energy of one rubber band was 0.099 newtons over meters. And we did an approximation of how many rubber bands we used, which was 650, and that gave me 63.35 newtons over meters. Thank you for looking at the project, and hope you enjoyed.